Hi everyone, welcome to our class. Today I am going to discuss about compound interest and how it is computed. A compound interest is obtained if the interest of the principal in one period is added to the principal amount and together will gain interest in the next period. That means the principal amount is increasing regularly by the addition of interest on it in every period. We have the compound amount. This is denoted by F. This is the accumulated amount of the principal amount and the compound interest. To have a clearer idea on how computation of compound interest differ from simple interest, let us make use of this diagram. So let us consider in here a 2-year period of using a money. So we have there the amount, the time or the computation of simple interest will always be per year. Then we have there the interest rate will always be an annual interest rate. So if initially an amount P was borrowed and it is used for 1 year, this money will gain an interest which is computed as P times R times 1 year. And in the second year, the same amount P will be used and gain again another interest computed as P times R times 1 year. So the future value of this initial amount P or the future amount after 2 years is computed as the initial amount, borrowed amount, plus the interest gained in the first year and and another interest which is gained in the second year or in the second period. So we have there F therefore is equal to P plus 2 times P times R, or we have the future amount of P is the future value of P will now be equal to P times 1 plus 2R. For the compound interest, we consider in here two periods. So we have an amount P. Take a look at this. We are using this time conversion period because in compound interest, it is not necessary that interest will be computed for 1 year. So interest can be computed either annually, semi-annually, bi-monthly, quarterly, daily, or weekly, depending on the agreed conversion period as agreed by the borrower and the lender. Okay, so we have the period rate I. So we are no longer using in here the interest rate. So depending on the conversion period, then you make use of the period rate, where the period rate I is equal to the annual rate divided by the number of conversion in one period. That is equal to M. So if initially you borrowed an amount P or an amount P is borrowed, after one period, this P will gain an interest P times I. So going into the second period, this time, this interest will be added into the initial amount which is borrowed. So you have in there, for the second period, the new amount that will be used will be P, the original amount, plus the interest. And together, the sum of the original amount and its interest will be subjected to interest for the second year. So it will be used for the second year, and this time it will be this amount that will gain another interest. So the interest is computed as, you have in there P times 1 plus I times the period rate, which is I. Okay, so the future value of the original amount P will now be equal to, in the last period you have in there, this amount plus the interest. Okay, so the future value of this P after 2 periods will now be equal to, you have this final value. So take note, every interest in each period is carried over as part of the principal amount in the succeeding period. And so the future value will now be this. You have P times 1 plus I plus the interest, which is P times 1 plus I times I. So simplifying, we have there two terms, common factor in each term. We have p times 1 plus I, so we factor that out. That gives us now the first term divided by this is 1, the second term divided by the common factor that gives us I, or the future value of the initial value p after 2 periods is now equal to p times 1 plus I raised to 2. In computation of compound interest, it is important that you know how to determine the compounding or conversion period, and this is denoted by M. So conversion period, this refers to the number of times in a year the interest will be compounded or converted into principal. So we have the different conversion period. If the conversion period is annually, that means M is equal to 1. If the conversion period is semi-annually, then M is equal to 2. Quarterly, that means every 3 months, so your M is equal to 4. Bi-monthly, conversion period is equal to 6. Monthly, you have 12. Weekly, M is equal to 52. This actually derived from 365 days in a week divided by 7 days a week. So it approximately gives us a conversion period, weekly conversion period of 52. Daily is 365. That means in any of this conversion period, the interest is computed and it is added to the principal amount. Okay. The period rate, which is denoted by I, is determined by simply dividing the annual rate divided by the number of conversion. So for example, if the annual rate is 10% and the money is, or it is agreed that the conversion will be semi-annually, so the computation of the interest in every period will be 10 divided by 2, or that is 5%. The total number of conversion periods, N, is equal to the total number of years times the number of conversion per year. Okay? Let us derive now the formula in computing the compound amount for the N period. So using these variables, P to represent the principal amount, I for the compound interest, annual rate is R, conversion period M, period rate is I, and number of periods N. Okay, so we start with computing the compound amount for the first year. So if N is equal to 1, the principal amount is the initial amount, which is P. The compound interest will be P times the period rate I, and the compound amount will be the sum of the principal amount plus the interest. And that gives us the compound amount equal to P plus P times I. And since P is common, we factor that out. It gives us the future amount, or the compound amount, is equal to P times 1 plus I. In the second period, meaning N is equal to 2, this compound amount in the first period becomes the principal amount in the second period. So principal amount will now be P times 1 plus I, and the compound interest will be this amount times the period rate. So we have P times 1 plus I times I. And the compound amount will now be the sum of the principal amount plus the compound interest. Okay, so we have two terms in here with this common factor, so we can factor that out. And we have the remaining factor will now be 1 plus I. So since the last two factors are the same factor, we can combine the two. That would give us the compound amount in the second period is P times 1 plus I raised to 2. It is important to note in here the relationship between this exponent and the period. Okay, so in the second period, you will have P times 1 plus I raised to 2. In the first period, where N is equal to 1, the compound amount is P times 1 plus I. This is raised to 1. Okay, we will make use of that pattern in the derivation of the formula. Okay, so we continue for the third period, and this time is equal to 3. And the principal amount this time will now be equal to the compound amount obtained in the second period, which was p times the square of 1 plus I. And the compound interest is the principal amount times the period interest I. And the compound amount will now be equal to the sum of the principal amount plus the compound interest. So as we look at this equation, so it contains two terms with the common factors p times 1 plus I raised to 2. So the remaining factor will be 1 plus I, and combining these two factors, 1 plus I, so you have p is equal, or f is equal to p times the cube of 1 plus I. So again, notice in here, n is 3, the exponent in here is also 3. So we have now derived the formula. At the end of conversion period n, you have the future amount, or the compound amount will now be equal to p times 1 plus I raised to n, where P is the initial amount, or the present value of the money, and I is the period interest, or the period rate of interest. Okay, the compound interest is computed by subtracting the compound amount, or the future value, minus the present value. To illustrate how compound interest is computed, let us solve this problem. Mona wanted to lend her 10,000 pesos to Lisa for 3 years at 8% interest rate. She wanted to determine what conversion period to apply that will give her the highest interest. Determine the compound interest if it is compounded annually, semi-annually, quarterly, bi-monthly, monthly, and daily. In each conversion period, find the period rate, number of periods, compound amount, and compound interest after 3 years. So we start our solution by identifying what are given. So the principal amount is 10,000 pesos. The annual interest rate is 8%, or 0.08 when converted to decimal, and the term is 3 years. And for each conversion period, or for each compounding period, we are required to find the period rate, number of periods, compound amount, and the compound interest. Okay, we start our computation by considering the annual conversion, meaning in 1 year, the amount will be converted only once. So the conversion period n is equal to 1. The period rate I will then be equal to, which is equal to R over M. So the annual rate divided by the number of conversion per year is equal to 0.08. Then the number of periods for 3 years will have n is equal to t times m. That is 3 times 1. We have 3 conversion periods for 3 years. The compound amount f, using the formula f is equal to p times 1 plus I raised to n. So with p equal to 10,000, then we have 1 plus the period rate, which is 0.08, and n is equal to 3. It gives us, after 3 years, the compound amount of the 10,000 pesos will now become 12,597 and 12 centavos. That gives us now the compound interest equal to the compound amount minus the principal amount. That will give us now 2,597 and 12 centavos. Now, if the money is converted semi-annually, meaning in 1 year, you're going to compound the amount twice. So it will be converted every 6 months. So the conversion period is equal to 2. The period rate I will be equal to the annual rate divided by the number of conversion period, which is 2. That gives us now 0.04. So this will be the interest that we are going to apply to the amount for every conversion period. or for one period. So the number of periods for 3 years, n is equal to t times m, 3 years, and in every year you are going to convert in twice, so you have a total of 6 conversion periods. The compound amount f again, so we have in here f is equal to p times 1 plus I raised to n. And since n is equal to 6, so we have now p is 10,000 times 1 plus 0.04 raised to 6, and it gives us the compound amount equal to 12,653 and 19 centavos. So you can now see a little difference of the future or of the compound amount. So if it is compounded annually, you have 12,597 and 12 centavos at the end of 3 years. If it is compounded semi-annually, the compound amount after 3 years will be 12,653 and 19 centavos, giving a compound interest of 2,653 and 23 centavos. If the amount is compounded quarterly, so we are going to convert the interest into principal amount every 3 months. That means in 1 year, there will be 4 conversion periods. Okay, so the period rate this time will be R divided by M, where the annual rate is 0.08, and there will be 4 conversion period, so the period rate will be 0.02. The number of periods, so for 3 years, the total number of periods will be 3 times 4 conversion period every year, so we have a total of 12 conversion periods or number of periods. The compound amount f again is computed using the formula f is equal to p times 1 plus I raised to n. And so we have substituting values. F is equal to 10,000 times 1 plus 0.02. We have the period rate raised to n, which is equal to 12. And that gives us the amount or the compound amount equal to 12,682 and 42 centavos. And the compound interest is the difference between the compound amount and the principal amount. That will give us now 2,682.44 and 42 centavos. Okay, so if the amount is compounded bi-monthly, meaning every 2 months the interest is computed and added to the principal amount. So in 1 year, there will be 6 conversion period. Okay, so the period rate I will now be equal to 0.08 divided by 6, and that is equal to 1 over 75. So the number of periods for 3 years will be equal to n is equal to t times m. So we have 3 years times there will be or there are 6 conversion period in 1 year. So we have a total of 18 number of periods. The compound amount f again is computed using the formula f is equal to p times 1 plus I raised to n. And substituting values, we have P is 10,000. Then we have 1 plus the period rate is 1 over 75 and N is equal to 18. That will give us now the compound amount equal to 12,692 and 35 centavos. Okay, so we have the compound interest I is the difference between the compound amount and the principal amount, and that gives us the compound interest equal to 2,692 and 35 centavos. Again, try to observe in here the interest or the compound interest after 3 years. As the number of conversion period becomes bigger, so we have been here 4, we have here 6, as the number of conversion period becomes bigger, you will notice that the interest is also bigger. Okay? if the interest is computed and converted monthly, that means there will be 12 conversion period for 1 year. So the period rate then that will be applied every month will be equal to R over M. The R is 0.08 and M is 12. And so we have 1 over 150. The number of periods for 3 years, since there are 12 conversion period per year, there will be 3 times 12 or 36 number of periods. The compound amount F, using again the formula, F is equal to P times 1 plus I raised to N, substituting values. That will give us now F is equal to 12,702 and 37 centavos. And the compound interest for 3 years will be F minus P. So you have 12,702 and 37 centavos minus 10,000. That is equal to 2,702 and 37 centavos. Now, if the amount is compounded daily, meaning the interest will be computed daily and converted to principal amount, there will be 365 conversion period in 1 year. And so we have the period rate I will be equal to R over M, that is 0.08 over 365, or we have 2 over 9,125. The number of periods for 3 years will then be equal to 3 times 365, and that is equal to 1,095. And so the compound amount F, using the formula, F is equal to P times 1 plus I raised to N, substituting values, that will give us now the compound amount equal to 12,712 and 16 centavos. And the compound interest, I, is F minus P, giving us 2,712 and 16 centavos. Again, notice in here the difference or the increase of the interest if it is converted monthly, and we have if the amount is converted every day or daily. Okay, so that we will be able to appreciate the effect of the conversion periods in the computation of compound interest. Let us now summarize our answers. So for the given principal amount of 10,000 and annual interest rate of 8% and for a term of 3 years, we have here, if the amount is compounded annually, so the conversion will be done once a year. And for the given amount, it gives us the interest is 2,597 pesos and 12 centavos. If the amount is compounded semi-annually, so we're going to convert the interest every 6 months. So there will be 2 conversion period per year, and the interest for 3 years will be 2,653 pesos and 23 centavos. If it is compounded quarterly, there will be 4 conversion period per year, and the interest will be 2,682.42. If it is compounded bi-monthly or every 2 months, in 1 year there will be 6 conversion period, and the interest is 2,692 and 35 centavos. If the amount is compounded monthly, and that means the conversion is done every month, so there will be 12 conversion period in 1 year. The interest for 3 years is 2,702 and 37 pesos. And if the amount is compounded daily, so the interest will be computed and converted every day. There will be 365 conversion period. And the interest is 2,712 and 16 centavos. So this is what is important to look at in here. You will notice as the number of conversion increases 1, 2, 4, 6, 12, and 365, you will notice that the interest is also increasing. So 2,597.12, and so observe this one. So it is actually increasing. That means in a compound interest, the more often the interest is computed and converted to principal amount, then the interest will be bigger also. Okay? So thank you. I will end up my discussion in here. I hope you learned something about compound interest. Thank you for watching.